only 33 are here, and whatever topic I'm doing now is really important. Okay, fine. Okay, so here first we'll go with the asynchronous counters. Asynchronous counters. Okay, so in the asynchronous counters, we have to design the asynchronous counter. Okay, so you have for our syllabus we'll be studying two counters here. One is mod 8 counter, okay, and the other one is mod 5 counter. Okay, so how to get mod 5 we'll see. Okay, but mod 8 counter. So can you tell me how many flip flops are required for mod 8 counter? How many flip-flops are required for mod 8 counter? Mod 8, this indicates the number of states. Number of states that it has to count. 3. Okay, in the same way, mod 5 counter. How many bits are required? Hey, mod 5. 5 is nothing but 5 states it has to count. 5 states. 5 states in the sense it has to count as like it has to start from 0, 1, 2, 3, 4. Okay, after 4 again it has to come back to 5. Okay, leave about this last one. It has to count from 0 to 4. How many bits are required to count 5 states? Okay, how will you write represent the last state? Last state is nothing but 4 here. 4. To represent 4, how many bits are required? How will you identify the number of bits required to count 4? See, 4, see the maximum number, see in mod 5 counter, it has to start from 0 and it has to count until 4 states. In the same way, mod 8 counter, it has to start from 0 and it has to count until 7. Okay, 0, 0, 0, 0, that is nothing but 0, 0, 0 to 1, 1, 1. Okay, so here all 8 states it is counting, so you need 3 bits. Okay, but when it comes to the mod 5 counter, it need how many flip-flops are required. So the number of flip-flops can be decided by number of the bits that are used. Okay, so if here mod 5 counter, it has to count from 0 to 4. Okay, so 4 is the maximum number. So to represent 4, how many bits are required? 2 2s are 4, 0, 2 1s are 2, 0. So 3 bits are required, right? So how will you decide on the number of flip-flops required? You can use, this is one more procedure, or I can even state that if this is mod m counter, so m value mod m counter, this m value can be less than or equal to 2 power n states. Okay, m value can be less than or equal to 2 power n states. Okay, see if you take 5. Okay, see 3 n value is 3, in the sense number of bits required is 3. Okay, so number of bits required is 3, in the sense like maximum number of states that it will count will be 8. Okay, so this m value, whatever number of states I'm counting, it can be less than that. Okay, but it cannot be more than 2 power n. Okay, so I am just telling you the ways to identify the number of flip-flops required. Okay, so the easy way is, so 0 to 7 states, 8 in the sense 0 to 7 states, it has to count, in the sense 0 to 2 power n minus 1 states it has to count. Okay, so 0 to 7 in the sense 7 try to represent it in binary. So 2 3s are 6, so 1 is left out, 2 1s are 2, 1 is left out, so 1 1 1 1 1 1 is the binary equivalent of 7. So I can say that I need 3 bits. So 3 bits in the sense 3 flip-flops are required. In the same way, let me just give you some example. Mod 24 counter. How many bits are required to represent 24? So mod 24 counter, in the sense how many states it will, from what state to what state it will count? 0 to 23, right? 0 to 23 states it will count. So 23 23 in the sense, how many bits are required to represent 23? So 2 ones are 2 ones are, so 1 is left out. 2 fives are 10, so 1 is left out. 2 twos are 4, again 1 is left out. 2 ones are 2, 0. So 1, 2, 3, 4, 5. 5 bits are required to implement this mod 24 counter. 5 bits in the sense I need 5 flip-flops. Hope this is clear to all of you.
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, fine. Just for my satisfaction, let me just give you one more example. Mod 45 counter. Mod 45 counter. How many states? From what state to what state it has to count?
0 to 44.
0 to 44. Okay, so you determine how many flip-flops are required. I'm not interested in the bits. I'm interested in the flip-flops. Still 33 only. I don't know. Afternoon you have got only my class, no?
Yes, ma'am.
That might be the reason to bunk the class. You people can post the message in the group.
Yes, ma'am.
Okay, fine. You can just post saying that all of you please attend the class. It is important. Anybody can post it. Tell me how many flip-flops are required to count this mod to design this mod 45 counter. This much time you are taking? How many flip-flops are required?
7, ma'am.
7. Okay, 44 divided by 2, 22. So this is 0, 11, 0, 2 5s are 0. Oh, sorry, not 0, 1, 1, 2 2s are 4, 1, 2 1s are 2, 0, 1, 2, 3, 4, 5, 6 only, no, ma?
Yes, ma'am.
Yes, ma'am. In
6.
the beginning, I
6.
made a mistake.
Okay, so 6 flip-flops. So you understood the concept, right? So how to identify the number of flip-flops are clear, right?
Yes, ma'am.
Okay, fine. Now we'll go with the asynchronous counters only. The only difference, see, identifying the number of flip-flops will remain same in synchronous also and in asynchronous also. But the only thing is in asynchronous, you'll have the clock connected differently. Asynchronous counters. Okay, in the asynchronous counters, as I've already mentioned, you have mod 8 counter, or you can even call it as 3-bit counter, 3-bit asynchronous counter, or asynchronous counter, or it is also said to be 3-bit ripple counter. Any of these names you see, you have to write whatever I'm going to teach now. Why it is called as ripple counter, I'll tell you later. Okay, so otherwise, as I've already mentioned, mod 8. So now tell me how many bits are required? 3 bits. Okay, so 0 0 0. It has to start from 0 0 0. Then it needs to count until 0 1 1 1 0 0 1 0 1 1 1 0. Oh, sorry, 1 1 0 1 1 1. Wait. Let me write again because I want to show something here. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, after this 1 1 1, it has to go back to initial state, that is nothing but 0 0 0. Okay, so this is how the counting will start. Okay, so clock pulses. I can say that here I'm counting the clock pulses. Okay, so let this be the output of the flip-flop. Okay, so Q2, Q1, Q0. Okay, be the output of some flip-flops. Okay, so now see here what should happen. Initially I will not give any clock and I'll make all the flip-flops is equal to 0. Okay, so how will you make all the flip-flops is equal to 0? By just giving the clear input. If you just make clear input is equal to 1, all the flip-flops will be turned on. All the flip-flops will be in the reset state. This you know, right? Yes or no, ma? Whenever I make clear is equal to 1, the Q value will be equal to 0. This you know very well. Okay. Now, my question here is just observe the states. Okay. So these are nothing but the output of the flip-flops. Q0, Q1 and Q2. All these are nothing but the output of the flip-flops. Right? Do you accept this? Yes or no?
Yes.
Okay, so what I need to do here is I need to design this asynchronous counter so that the flip-flops outputs, okay, this Q2, Q1, Q0 will be initially 0, 0, 0. Next, after that, it will be 0, 0, 0, 1. After that, it is 0, 1, 0. After that, it is 0, 1, 1. Like that, it has to count until 7, 1, 1, 1. And after 1, 1, 1, it has to go back to 0, 0, 0, 0. Okay, so this is how it has to count. Okay, so if I want to get the output, so see, now I have identified how many flip-flops are required. Since I need 3 bits to represent, to design the mod 8 counter, I need 3 flip-flops. That is over. Now what I need to do, which flip-flop I need to use? Out of 5 flip-flops, which flip-flop I need to use? That is what the next question. So how many flip-flops is over? Now which flip-flop I need to identify? So just to check the output of the first AND gate. No, first Q0. Okay, how is it, ma? How is it? How is the output? Just observe this complete output and tell me how is this. How is this? How is this, ma? 0. First I have 0. Second I have 1. Again it is 0. Again it is 1. Again it is 0. Again it is 1. Again it is 0. Again it is 1. Again it is 0. What is happening here? If initially I have 0, the next value is 1. If I have 1, it is changing to 0. If I have 0, it is changing to 1. If I have 1, it is changing to 0. If I have 0, it is changing to 1. So if I have 1, it is changing to 0. If I have 0, it is changing to 1. If it is 1, it is changing to 0. What is happening here? There is one specific name for this, no?
It's complement.
No. Flip-flop. With respect to the flip-flop, there is one specific name for this. Complement is happening. When this complement will happen?
Invert.
Oh, no. Flip-flop. You speak with respect to the flip-flop. Just think. See, I'll be asking you the questions only like you give some like what is that? Some work to your brain. That's it. Anybody else, not only like a specified person has to answer, it is for everybody. So what is happening here? I'm asking you to speak or to use the terminology of flip-flop. Okay, I will only tell you. Toggle. Toggle. Toggling is happening. Yes or no? Toggling means what is happening? If initially the value is 0, it is changing to 1. If it is 1, it is changing to 0. If it is 0, it is changing to 1. So toggling is happening. Okay. So now can you tell me which flip-flops I need to use here? Which flip-flop I need to use here? Okay. First let us name the flip-flops. You have SR flip-flop, JK flip-flop, master slave JK, then D flip-flop, then you have T flip-flop. So which flip-flop I need to use here? Out of this 5, which flip-flop I need to use? Like only the first one. You tell me about the first one. Second one, how to get, I'll tell you. Toggling is happening. So initially, see, I've told you that initially I'm making all the flip-flop outputs to be 0. How I'm making it? Just by making CLR is equal to 1, I'll make all the flip-flops outputs as 0. Okay, that is fine. Now, my question is, here Q0, you just take Q0 output only. So what is happening with the Q0? The present state was 0. The next state is 1. Okay, again, if that is the present state, the next state is 0. If again that is the present state, the next state is 1. If that is the present state, the next state is 0. So if you observe, everything everywhere in the Q0, it is toggling. Toggling is happening. So in which flip-flop the toggling will happen, and when this toggling will happen? That is what my question. Which flip-flop and when? Will you be able to answer it? Will you be able to answer it, Ma? Okay, fine. I will only tell you. You need to go with the toggle flip-flop, T flip-flop. Okay, so I'll just draw the T flip-flop. T flip-flop was like this, right? This is J and this is K. Okay, anyway, you'll have the clock. Okay, that is a different story. Okay, then you T. Okay, T will be given to J also and K also. If I give T value is 0, both will be 0, and my Q and Q bar will stay in the same state under no change. Okay, when I give 1 to it, what happens? What happens when I give 1? If my present state is 0, my next state will be equal to 1. If my present state is 1, the next state is equal to 0. Hope you people are able to recall the table of this T flip-flop. Yes?
Yes, ma'am.
Okay, so here to get Q0 directly I can use toggle flip-flop, which is nothing but the T flip-flop. Okay, fine. I have got the first flip-flop, which is nothing but Q0. Q0, it is toggling. So what I need to do, I need to provide T input as 1 and T input as 1, and let me draw that properly. Let me draw it properly. Okay, so first what I'll do, I will take T flip-flop. Okay, so T flip-flop I have taken. Okay, let me name this T1. Okay, T0 only. Let me name it as T0, or I'll change the names here. Let me name this as Q1, Q2, Q3. Q1, Q2, Q3. Okay, let me name this as T1 then. Okay, T1. So I'll give the clock. Okay, I'll give the clock so that and T1 value I'm giving as 1, so that whatever Q1 I'm getting, it will toggle. Okay, toggle in the sense, if I give a if the present state is 0, the next state when I give the clock pulse, it will become 1. When again I give the clock pulse, it will become 0. When again I give the clock pulse, it will become 1. When again I give the clock pulse, it will become 0. Okay, this toggling will happen. Okay, this is my first flip-flop. Okay. Somebody has come, I think so. Okay, fine. So this is my first flip-flop. Okay, so now again check with the second one. Okay, check with the second. Oh, is the first one clear to all of you? First one is clear to all of you?
Yes,
How I've got the T flip-flop and why the T value is 1. Is that clear to all of you? Because what should happen with the T flip-flop, the first flip-flop, it has to toggle the output. In the sense, if I have a 0, it should change to 1. If I have a 1, it should change to 0. If I have a 0, it should change to 1. Like that, the toggling effect should happen. That is the reason I've chosen toggle flip-flop and I've given 1 to that and also the clock signal. Okay, and next, again I need to get second one. Okay, let me just draw the other two flip-flops also. Anyway, I came to know that I have to use toggle flip-flop only. All the 3 flip-flops will be the toggle flip-flop only. So this is my T2 and I'll get Q2 output. Okay, then, and as I've already mentioned, I'll have the clock, but in the asynchronous, I'll not give the clock simultaneously. Simultaneously in the sense, directly from here I have to connect. Okay, but what I'll do, I'll not connect in this way. Okay. If I connect this way, it will become synchronous. Okay, but here I need to connect the clock, only then this will work. Okay, so now Q1 is toggling 0 1 0 1 like that, it is toggling. Okay, now check the Q2. This is my Q2. This is my Q2. Okay, so here again you check. See, initially it is 0. The next also it is 0. Okay, and then it is 1. Okay, so after this state it is 1. Okay, if you just observe. Okay, again next and again I have 1. Okay, and here only here you can see the change. Only here you can see the change. See, toggling is happening only here. From here to here toggling is happening. From here to here toggling is happening. Again from here to here toggling is happening. Again from here to here toggling is happening. Okay, so you just check how the Q1. See, I'll tell you one thing. You need to connect from Q1 so that it will toggle. So when the toggling is happening, when Q1 is changing from 1 to 0, Q2 is changing from 0 to 1. Okay, it is toggling, right? Yes or no, ma? Just check the inputs again. See, here I'll not give clock simultaneously, and you know that the toggle flip-flop will toggle only when I provide the clock signal, right? Complete clock signal, only when I give complete clock signal. See, this bubble indicates it is trailing edge triggering. Trailing edge triggering in the sense, if the clock is changing from 1 to 0, then only that the output will trigger. Okay, so and the T2 value should be 1. In the same way, this 3 also should be 1. Okay, that is compulsory. Okay, only when the T input is 1, it will toggle. And how it will toggle? Based on the clock pulse. Okay, so how the clock pulse should be connected. So if you observe, see, whenever Q1 is changing from 1 to 0, see, here you just observe the first one. 0 to 1 change, the Q2 is same. Q2 is not changing. Q1 is changing from 1 to 0, Q2 is changing from 0 to 1. Okay, again Q1 is changing from 0 to 1, so no, the next state of this is same. See, here I have 1, so here also I have 1. Next again, Q1 is changing from 1 to 0, so here the toggling is happening. From 1 to 0 it is toggling. Again 0 to 1, no toggle. And 1 to 0, the toggling is happening. Again 0 to 1, no toggling. 1 to 0, the toggling is happening. So what I can do is, I can give the Q1 as a clock input to this second flip-flop. Okay, so whenever I give Q1 as my clock input to the second flip-flop, what happens whenever Q1 is changing from 1 to 0, this indicates that whenever Q1 is changing from 1 to 0, the toggling will happen. Okay, that is what it indicates. Okay, in the same way, you just observe the next Q3. Hope you people are following. Now you just analyze for Q3, then you'll understand. Q3 where the toggling is happening only at this point. At this point the toggling is happening. Again the last one, the toggling is happening. So how the Q2 should change so that this toggling should happen? So 0 to 0, Q2 is 0 to 0, no change. 0 to 1, no change. 1 to 1, so no change. 1 to 0, here that Q2 is changing from 1 to 0. So the Q3 is toggling from 0 to 1. In the same way, 0 to 0, so no toggling. See, it is still in the same state. Again, here only at this point, Q2 is changing from 1 to 0. So what is happening? The toggling is happening. So here also I can connect Q2 to the clock of third flip-flop. Okay, so that whenever Q1 is changing from 1 to 0, the second flip-flop will toggle, and whenever Q2 is changing from 1 to 0, this flip-flop will toggle. Hope this is clear to all of you. Are you all understanding?
Yes, ma'am.
Yes, ma'am.
I'll just explain you reverse way in the sense I have drawn the circuit now, and I'll explain its operation. I'll do it in 2 different ways. If you're not understanding also, no problem. Let me just teach you in 2 different ways. Okay, initially what I'm doing, I'm making all the flip-flops outputs as 0. All the flip-flops outputs I'm making it as 0. Okay, initially I'm making all the flip-flop outputs are 0. How I'm making, I'm just giving clock CLR value is equal to 1, so that this will become this will reset the flip-flop. Reset in the sense it will make all the output values is equal to 0. So everywhere I'll give CLR is equal to 1, CLR is equal to 1, so that the flip-flop output will be equal to 0. Okay, and I've given all the T inputs to 1 because the toggling has to happen. Okay, so toggling has to happen. So and how the connectivity should be for this toggling to happen, so I'll tell you. Okay, so first 0 0 0 are my inputs. Now I'm giving the clock signal. Okay, clock signal is given. Okay, when clock signal is given, this Q1, the output of this will be equal to what? The output of this will be equal to what? What will be the output here, ma? I have given clock signal and I made T1 is equal to 1. So the present state is 0. So what will be the next state?
0.
Hey, no. It will be 1, right? See, T is equal to 1. Your next state Qn plus 1 is nothing but Qn bar, right? This is what the truth table of your T flip-flop. Is it confusing? Is it confusing?
No, ma'am.
Okay. So let me just take. So first all the flip-flops outputs are 0. Okay, now what I'm doing, I'm giving a clock signal here. Okay, and T1 value is 1. Okay, clock signal is 1 and T1 value is 1 and the present state is 0. Okay, so here one more thing, only when you give the complete clock it will toggle. Okay, so I have given the complete clock now. Okay, so what happens, 0 will change to 1. Okay, and here what is happening, that is given as an input to the clock of your this one, second flip-flop. This is the first flip-flop, flip-flop 1, flip-flop 2, flip-flop 3. Okay, so here the clock signal is nothing but input from Q1. Okay, Q1 is changing from 0 to 1. Will it toggle? Will this toggle? You have a circle here. So this circle indicates only when the change is from 1 to 0, this flip-flop will toggle, right? Are you understanding, ma? Are you finding it difficult to understand?
No, ma'am.
Okay. So here I have the bubble. This bubble indicates it is trailing edge triggering. Trailing edge triggering in the sense, whenever the clock signal is changing from 1 to 0, then the output of that will toggle. That is what it means. Okay, so let me just explain it again. So first I have given, initially I made all the flip-flop outputs is equal to 0. Okay, and T1, all the flip-flop inputs I have given as 1. Okay, the reason behind that is only when T value is 1, the output of that will toggle. Okay, that is the first condition. Now, initially, first I have given clock signal here. Okay, when I have given clock signal, the output of the first flip-flop will change to 1 because clock is complete clock is there and T value is 1 and the present state is 0. So since the present state is 0, the next state will be equal to 1. Okay, and if you observe, the Q1 is changing from 1 to 0. Okay, it is like this. Q1 is changing from 1 to 0. So will the second flip-flop toggle? That is what my question. Will it toggle? Will it toggle?
No, ma'am.
No. So what will be the output? Same state. Right?
Yes,
It
ma'am.
will be in the same state. Why it will be in the same state? Because I'm not getting the clock. Clock is 0. There is no proper clock there. Okay, clock is 0. Okay, clock is 0. It's not 0. It is not changing as required. See, this bubble indicates it has to always go from high to low. Only when it is going from high to low, the output will change. Okay, but that is not happening here. It is not changing from 1 to 0. It is changing from 0 to 1. So this will not toggle. It will be 0 only. And again, this Q2 is given as an input to the third flip-flop. Even here I have the bubble. It means that if the Q2 value is changing from 0 to 1, 1 to 0, then only the third flip-flop will toggle. But what is happening here? 0 to 0. Okay, so is it changing from high to low? 1 to 0? Is Q2 changing from 1 to 0?
No, ma'am.
No. So what happens to the output of third flip-flop? What happens to the output of third flip-flop? Will it stay in the same state or it will change its state?
Same state, ma'am.
Same state. Same state means what will be the output? It will be equal to 0. Okay. Is this clear? So first I have got as 0, 0, 0. Next I have got as 0, 0, 1. See, you have to count from here. That's the reason I have written Q3 first, Q2 first, and Q2 next, and Q1 next. Okay, so 0, 0, 0. Next 0, 0, 1. Is it clear? Is this state clear? Okay, fine. Next, let me go to the next one. Okay, again I'm giving the clock. Here the clock will be given continuously. Here the clock will be given continuously. Okay, only here there is delay. Okay, only when this changes, this changes, this changes, this changes. Okay, so fine. Now again I have given a clock. Okay, since I have given a clock, what happens to this? Okay, t is 1. The present state is 1, and I have given the clock. What happens to this Q1 output? It will be equal to I've given one clock signal, ma. See, I have given one clock signal, so that I've got 0, 0, 1. Okay, now I'm giving one more clock signal. Okay, one more clock signal. So one more clock signal is given. What happens to the first flip-flop output? What happens to the first flip-flop output? Whether it will be same 1 only or it will change to 0. Question is not clear for you? Is the question clear to you? Okay, let me write. So first I've given first initial I made all the flip-flops is flip-flop outputs is equal to 0. Then I've given the clock pulse. So the first flip-flop will toggle because the clock signal is there. And the t value is 1 and the present state is 0. If the present state is 0, then it will change its state to 1. Okay, now if you observe, the second flip-flop has got the output from the Q1. Okay, Q1 is toggling from 0 to 1. When Q1 is toggling from 0 to 1, it will not be active because only when only when the clock signal is changing from 1 to 0, this will become active, and based on the inputs it will act. Okay, but here the clock signal is not according. Okay, only when I get from high to low, this flip-flop will toggle. But what is happening to this? The input is nothing but Q1. Q1 is changing from 0 to 1. 0 to 1. 0 to 1. Okay, so 0 to 1, this will not, this clock is inactive. Okay, clock is I'm not getting the correct clock. Okay, since the clock is not correct, the output will not change. Okay, because only when a clock is from high to low, only then this output will toggle. Okay, but here I have not got 1 to 0, I have got from 0 to 1. 0 to 1 change I'm getting. Okay, since 0 to 1 change I'm getting, this second flip-flop will not toggle, it will remain in the same state. Same state in the sense the present state was 0, the next state will also be equal to 0. Here when it comes to the third flip-flop also same thing. See, whenever you are checking for the clock should be always from 1 to 0. Only then the output will trigger, output will change, or output will toggle. Okay, but if you observe here Q2 is connected as clock. Q2 is changing from 0 to 0. So the output will remain in the same state. Present state is 0. So the next state is also 0. Now let me consider again I have given the clock signal. Okay, one more clock I have given T1. All this T1, T2, T3 are fixed 1. Okay, now I have given 1. So what happens to the output of this Q1? Now the present state is 0 here, 1 here, 0 here, and 0 here. Okay, so what happens to the output here? It will toggle, right, Nama? I've given the clock signal which is changing from 1 to 0, and I'm also given t value as 1. So what happens to the next state? Present state is 1, so the next state will be equal to 0, right?
Yes, ma'am.
Okay, so now if you observe, the Q1 is changing from 1 to 0. So the required clock I've got 1 to 0, it is changing. Q1 is changing from 1 to 0. Since Q1 is changing from 1 to 0, I'm getting the edge triggering. Okay, edge triggering for the trailing edge triggering for the flip-flop 2. So what happens to the output here? Will it toggle or it will not toggle? Are you feeling difficult in understanding?
No, ma'am.
Then tell me what is the output here? It will change its state or it will remain in 0 only. See, the only thing is it can be either 0 or 1. So now my Q1 input is changing from 1 to 0. It means that it is changing from 1 to 0, high to low, trailing edge triggering. It is getting trailing edge triggered. So my question is whether the next state will be 0 or 1. Which is correct? 0 or 1?
Ma'am,
change.
1.
1. Very good. Very good. 1. Okay. So again, see here. See the Q2. Q2 is changing now from 0 to 1. Initially it was 0. Now it has changed to 1. So am I getting the correct clock? 0 to 1. Am I getting the correct clock? Trailing edge triggering is happening here or not?
No, ma'am.
No. So what happens to the output? Will it remain in the same state as 0 or it will change its state to 1? Toggling
Same
will happen
state.
or toggling will not happen. Okay, fine. Now, again, I'm giving one more clock. Okay, so now if you observe, I've got 0, 1, 0 as my next state. See, when I gave the next clock, it has the output has changed to 0, 1, 0. Okay, now again, I'm giving one more clock. Okay, one more clock is given. Okay, so what happens to the output here? Output of the first flip-flop will be, this will always toggle because I'm giving the clock directly here and I have T1 is equal to 1. Okay, so what happens to the clock here? Sorry, Q1 output. What happens to Q1 output? Toggling will happen or not?
It will happen, ma'am.
So what will be the value?
0.
0 is there, no? Present state is 0. So what will be the output now?
1, 1.
1. Okay, so now again Q1. Q1 is changing from 0 to 1. So 0 to 1. Am I getting the trailing edge triggered clock pulse? 0
No,
to
no.
1 it is changing. No. So what happens to the output? Will it remain in the same? Same. What was the previous present state? 1. So even now it will not change its state. It will be still 1 only. Okay, let me write here. Okay, 1. So again, you just check. Q2. Q2 is from 1 to 1. Am I getting the trailing edge triggered clock here?
No, ma'am.
No. So what happens to the output?
It remains the same.
Same. Very good. Now again, so if you observe, I've got a 0, 1, 1 as my next state. See here. 0, 1, 1. When I gave the clock pulse, I've got 0, 1, 1. Now again, I'll give one more clock pulse. Okay, one more clock pulse is given. Here I'm giving the clock pulse. So what happens to the output here? Will it toggle? Present
Yes,
state is
ma'am.
1. So the output will be equal to 0.
0.
Okay, so now observe the Q1. Q1 is changing from 1 to 0. So what happens to the, am I getting a trailing edge triggered clock?
Yes,
To
ma'am.
flip-flop to? Yes. So what happens to the output?
1.
It is 1. Present state is 1.
The next state is 0.
0. Okay, fine. Now again Q2. Q2 is changing from 1 to 0. Am I getting trailing edge triggered to the third flip-flop?
Yes, ma'am.
See, trailing edge triggering is happening. Okay. So what happens to the output of the flip-flop 3?
It becomes 1. I mean, it remains the same.
Yeah. No. It will become 1 because it is Q2 is changing from 1 to 0. So Q2 is changing. The third flip-flop will toggle. See, the present state is 0. So it is changing to 1. Okay. Now again, see, if you observe, I've got 1, 0, 0. So see here, 1, 0, 0. Now again, I'll give one more clock pulse. So here one more clock pulse is given. Okay. So what happens to the output of the first flip-flop?
It
Toggles,
becomes
right?
1.
It becomes 1. So Q1 is changing from? Q1 is changing from?
0 to 1.
0 to 1. So yeah, am I getting the correct clock?
No, ma'am.
No. So what will be the output?
It will be the same. 0.
Same in the sense 0 only. Okay. So observe the Q2 output, how it is changing. Q2 output is changing from 0 to 0. Right. So am I getting the correct clock to the flip-flop 3?
No, ma'am.
No. So what happens? it will not toggle. It will stay in the same state. So 1. So see 1, 0, 1. That is what I've got as my output. Yes or no, ma?
Yes,
Hope
ma'am.
people are understanding. Now I'll give one more clock. So one more clock is given. Okay. So one more clock is given and T1 value is 1. So what happens here? The output of this flip-flop, first flip-flop, will it toggle or not?
Yes, ma'am, it will toggle.
So 0. So Q1 is changing from 1 to 0. Okay. So am I getting the proper clock here to the
Yes,
second
ma'am.
flip-flop? So what happens to the output?
1. It becomes 1.
1. Okay. So see the Q2. Q2, what is happening with Q2? Q2 is changing from
0 to 1.
0 to 1. Am I getting the correct clock to the third flip-flop?
No, ma'am.
No. So what happens?
It will remain same.
Same state. Same state is nothing but 1. So see, when I've given the clock, I've got as 1, 1, 0. See, 1, 1, 0. Now I'll give one more clock. One more clock pulse. Okay, so one more clock pulse is given. Okay, so what happens to the first flip-flop? It will toggle. It will toggle or not? I've given one more clock pulse. So will it toggle?
Yes, ma'am.
Okay, so it is 1. So this flip-flop is changing, its state, Q1 is changing from 0 to 1. Am I getting correct clock to the flip-flop 2?
Yes, ma'am.
Hey, am I getting correct
Oh,
clock
sorry.
to the...
No,
No,
ma'am.
right.
It
See
won't
how
toggle.
it should be like 1 to 0, but it is from 0 to 1. Am I getting the correct clock? No.
No.
So what happens to the output? Same
Remains the
state.
same.
Same. So it previously it was 1, so again it will be 1 only. Okay, now if you check Q2, Q2 is changing from 1 to 1. Am I getting the correct clock to the flip-flop 3?
No, ma'am.
No. So what happens to the output?
1.
1 only. Okay. Now again, so if you observe, it is 1, 1, 1. Okay, 1, 1, 1. Now again, I'll give one more clock. Okay, so one more clock. This is the first flip-flop. Will it toggle or not? First flip-flop will always toggle, no? Because I'm giving direct clock there only. Okay, so will it toggle?
Yes, ma'am.
Okay, so 1 to 0. Okay, so if you observe 1 to 0, 1 to 0. Okay, the Q1 is changing from 1 to 0. Am I getting correct clock to flip-flop 2?
Yes, ma'am.
So what happens to the output?
It becomes 0.
It becomes 0. Okay, so again, the Q2 output is changing from 1 to 0. Am I getting correct clock?
Yes, ma'am.
To flip-flop 3. So what happens to the output?
0.
0. So did I get all zeros in the last state?
Yes, ma'am.
So if you just come back, I hope it is clear to all of you. Okay, like I'm not asking each and every person because I'm already lagging with time. Okay. So if you observe, see what is the function of the counter? The function of the counter is it has to count from it has to count in terms of binary. Okay, so here it is mod 8 counter. Mod 8 counter using 3 bits it has to count. Okay, so initially I have set all the values is equal to 0. Okay, so it started counting from here. Okay, so here specifically I can say that it will count to the number of pulses. Okay, so what happens? First I have given the first pulse. Okay, so I've got 0, 0, 1. I've given second pulse. I've got 0, 1, 0. I've given third pulse. I've got 0, 1, 1. I've given fourth pulse. I've got 1, 0, 0. I've given fifth pulse 1, 0, 1. Sixth pulse 1, 1, 0. Seventh pulse 1, 1, 1. Eighth pulse 0, 0, 0. After this, what happens? Again, it will start counting. Okay, so this counter is made to count the number of pulses. So here if you observe, it has counted 8 pulses. So that is the reason it is said to be mod 8 counter. This is very, very important. We'll be using in many of the applications. The counters will be used in many of the applications. Okay, as an example, I've already told you. So if I want to take the attendance, like how many people are present in that particular class. Okay, so what I'll do, I'll just connect to some sensor and that sensor should count how many people are inside. I don't need which person is inside. I just need the count. Okay, so what initially I'll set the counter value is equal to 0. Okay, that is the reason. Maybe when you people are doing CPS lab, I don't know how many or like maybe it has started or not, that I don't know. Okay, in this counter initially will make it as 0, right?
Yes, ma'am.
Okay, so this is the main thing. Okay, so what I'll do initially, I'll make counter value is equal to 0. Okay, as the people starts coming into the class, the sensor will sense that value and it will increment that count. Okay, this is one of the application. Practically, I'm telling you, this is one of the application. Okay, so this is your mod 8 counter, which is counting from 000 to 111 states. Okay, hope this is clear to all of you. Then again, this will continue 001, 010, like that it continues. Okay, but the number of states it is counting is 8. Number of pulses it is counting is 8. Okay, so whenever they ask you to write about this asynchronous counter, you need to first draw this diagram, then draw this truth table and explain it. Okay, why when this second flip-flop will toggle, when the first flip-flop will toggle, and when the third flip-flop will toggle, related to that you need to give some explanation. Okay, fine. So I told that this is also said to be the ripple counter. Okay, the reason for calling this as ripple counter is, see, if you observe, until and unless I get the output from the first flip-flop, the second flip-flop will be inactive only, right? Only when after getting the output from this, based on that output, this will trigger. Okay, so again, based on the second input, second output, the third flip-flop is acting. Right, so what is happening, if this flip-flop is having some delay, that delay will get added with the second flip-flop delay, then second flip-flop delay will get added with the third flip-flop delay, and overall what is happening, the delay is getting rippled. That is the reason this is also said to be the ripple counter. Okay, so that is the main reason I have given you all the names. Maybe in the exam they may ask whether mod 8 counter or 3-bit asynchronous counter or just a 3-bit counter, or they may even ask us 3-bit ripple counter. So you should write the same whatever circuit I've shown you. For that circuit only you need to give the explanation. Okay, hope this is clear to all of you. Hope this is clear to all of you. Okay, I'll give you the timing diagram also. Okay, clock. I have clock. Let me consider. Okay, let me draw it properly. Just I'll finish this and I'll leave you. Don't worry. Let me take the clock signal. As I've already mentioned, the clock signal will have the positive half and the negative half cycle, on period and the off period. Let me take like this. Okay, fine. Now Q0. Sorry, Q1 output. Okay, Q1 output. And you know that whenever the clock is changing from 1 to 0, only then the output will change. Only then the output will change. See, only at this location the clock is changing from 1 to 0. That's why I'm just putting these arrows to just indicate that where the change is happening. Hope all of you have understood. Okay, just go through it once again. You just analyze it on your own. Okay, if you just analyze on your own, then only you'll understand. Okay, okay, fine. Let me not draw this because next one it will be different. Only for the first one this will be applied. It will not be applied for everything, all the outputs. Okay, fine. So initially Q1, Q2 and Q3. Okay, initially all the values are, I'm making it as 0. Okay, so all the values are zeros. Okay, all the flip-flop outputs are 0. Okay, so first flip-flop, whenever t is equal to 1 and clock is equal to, clock is changing from 1 to 0, this output will change from 0 to 1. Okay, so it will be 0. Okay, it will be 0. And here if you observe, I have the trailing edge triggered. So Q1 will change from 1 to 0. Okay, and 1 to 0, and this state will continue until I'll get one more trailing edge like this. Okay, so this will be continued until here. Okay, again I got clock changing from 1 to 0. So this Q1 output will also change from 1 to 0. In the sense, initially it was 0, it will change to 1. Sorry, it was 1, it is changing to 0. So until I get the next clock pulse, next triggering edge. Okay, so here again I got the triggering edge. The Q1 will change from 0 to 1. Okay, so again here I got the trailing edge, so it will change from 1 to 0. Next again 0 to 1, and this will continue until I get the trailing edge like this. Again it will change its state 1. Again it will change its state 0. Again it will change its state 1. Again here I got the trailing edge, so again it will change its state to 0. Okay, hope this is clear to you.
Yes, ma'am.
Okay, now Q2 output. Okay, Q2 output. When this Q2 output will change, this Q2 output will change only when your Q1 changes from 1 to 0. Okay, so the same thing. So here if you observe, this is your Q1 pulse. Whenever Q1 is changing from 1 to 0, then only Q2 will change 1 to 0. Here also 1 to 0. Then here, where is that? This is 0. Hey, I've written it wrongly, no? 1 0 1 0. Okay, so this is 0 1 2 0 1 2 0 1 2 0. Okay, so at all these locations the Q2 will trigger, otherwise it will continue to be in the 0 state only. So it will continue in 0 state until I get this trailing edge triggered. Okay, so its value will be 0 only. Here also here it will change its value from 1 to 0. Sorry, 0 to 1. 0 it is, so I got the trailing edge. So what it will do, it will change its state from 0 to 1. It will continue. So here it is from 0 to 1, so it will not. Again I got trailing edge here, so it will be 1. Here also it will be 1, and then it will change its state because I've got the trailing edge trigger of Q1. So later on it will continue to stay in the same state. Okay, again I've got trailing edge here, so it will change its state to 1. So again until I get this trailing edge, it will stay in the same state, and then finally okay, here again I got the trailing edge. So what it will do, it will change its state. So this is 0. Okay, now coming to the third one. Q3 flip-flop. Okay, Q3 flip-flop, it will toggle only when your Q2 is changing from 1 to 0. 1 to 0. So just observe, here only it is changing from 1 to 0. Only here it is changing from 1 to 0. Okay, only here it is changing from 1 to 0. See, Q2 is changing from 1 to 0 at this point. Q2 is changing from 1 to 0 at this point. So only at this point the Q3 will trigger. Otherwise it will remain to be in the same state. 0, here also 0, here also 0. Again here I got trailing edge triggered. Okay, so it will change its state to 1, and this 1 will continue until I get one more trailing edge for Q2. Okay, so here again it changed. Okay, so if you observe, 0 0 0 0 0 1 0 1 0 0 1 1 0 1 1. You read from Q3 to Q1. Okay, 1 0 0 1 0 0 1 0 1 1 1 0 1 1 1, and again it is going back to 0 0 0. So this is the other way of explaining the same circuit. Okay, whichever you feel comfortable you can explain. Both I have given in the notes. Okay, whichever method you feel comfortable you can use that. Okay, is this clear, ma?
Yes,
Yes,
ma'am.
ma'am.
Anybody has got any doubts, you can ask me, otherwise the class is done for the day. I'll in the tomorrow's class I'll explain you mod 5 counter. Mod 5. Actually no, I thought I'll finish mod 5 also and synchronous counter also today, but I don't know, it took a lot of time. Hope it is clear to all of you. Anybody has got any doubts, please ask me, otherwise the class is done for the day.
No notes.
Okay, ma'am.
Thank you, ma'am.
Thank you, ma'am. If anybody has any, thank you, ma. If anybody has any doubts, please ask me. I don't know why you people will not speak to me. Abhimanyu?